Hey, what's up guys, this is Audie from Sauce Nation, and today we're going to be talking about how to name organic compounds. So I think that organic naming can be the most confusing part of the nomenclature just because of how many things you have to remember, but I will try to make things as easy as possible. First, we must determine what an organic compound actually is. Well, in the simplest terms, an organic compound is anything that has carbon and hydrogen in it. Okay, so now let's talk about the three, there are actually three ways of drawing these structures, and I'll go through and how to recognize. So the first way is the condensed form, and this is what it looks like. So this is where the entire molecule is actually, well, condensed, right? And so when it is condensed, we can get a better view of what the molecule is, instead of having to write out everything. This leads us to the second part where, which we call the chain form, where we can actually see the structure of the molecule in a two-dimensional form factor instead of a three-dimensional. And this is not the actual representation of the molecule, it's just a drawing of it. So in order to convert from the chain form to the condensed form and vice versa, you need to actually understand what's happening to the carbons in the molecule. And that's for another video. We're not going to talk about it right now. So let's move on with actual naming. Alright, so the last form of writing a compound is actually the what I call the zigzag method. And so what the zigzag method does is it shows the actual form of the molecule in a two-dimensional form. So the actual molecule will be in a zigzag form instead of the right angle form that we saw in the chain form of the molecule. Now with all of that done, we have to talk about the prefixes. So similar to covalent naming, we actually have prefixes in the organic naming too. So here they are. Pause the video if you need to. Okay, so now let's look at an example. All I want you to do is find the prefix for, or the root word for this molecule right here, based on the number of carbons. Pause the video if you need to. Okay, so this would be called pentane, but all you would need to do is say it's pent, that the root word is pent because it has 5 carbons. Alright, so let's look at another example. This molecule would be called octane because it has 8 carbons and in the longest chain. Now remember that the molecule has to be in the longest chain. We'll talk about that later when we go to branching and things like that. Alright, so now that we know how to name the actual molecule, let's talk about substitutes. So the thing with organic molecules is that they don't have to be in straight lines. They can actually have branches, so let's start off with that. So one type of branch is actually called an alkyl group, which is basically a CH3. So when naming these, you have to first identify the longest chain of carbons. Remember, these can be bent. So for example, the longest chain of carbons in this molecule would be 4. Alright, so let's try an example. Pause the video if you need to. This molecule would be called nonane because the branch is still a part of the longest chain, which has 9 carbons. Now let's look at this molecule. In order to name this, we would actually have to recognize that the longest chain is 4. After this is done, we have to mention what carbon the branch is on. Remember to always start at the side closest to the branch and then count them off. In this case, the branch would be off to the second carbon and not the third carbon. Okay, now we just have to name it. So in this example, we have a methyl group that's attached to the second carbon atom in the butane molecule, and so we would call it 2-methylbutane. Alright, now you can try an example. Pause the video if you need to. So in this case, the answer would be 2-ethyl 3-methyl pentane, because the longest chain is 5 carbons long, and there's an ethyl group on the second carbon and a methyl group on the third carbon. Alright, so now let's talk about how things change when double and triple bonds are added. So in the case of a double bond, we would actually have to change the ending of the name. So from butane, in this case, from butane, we would have to change it to butene because it has a double bond in it. Alright, everything else is the same. The same goes for a triple bond, but all you need to do is change the ending to -ine, Y-N-E, and so in this case, we would have to call this molecule butane. Now things change when you have multiple double or triple bonds. So in this molecule, we have one triple bond and then one double bond. So we have to specify where the double bond is and where the triple bond is, all at the end, and also indicate that we have a double bond and a triple bond. So we would do all of that at the end. Alright, so with all of that done, let's go ahead and get the answer, which would be but-3-ene, 1-ine. I know it's a really complicated name, but this is how it works. Alright, so with all of that out of the way, we can actually talk about functional groups. Alright, so the first functional group we'll talk about are halogen substitutes, or halosubs. So basically, this is where a hydrogen is taken out and a halogen is put in. And so if you don't know where the halogen family is, it's actually the row right before the noble gases, or the last row. So it's the 7th group, or if you're using a different system, the 17th group, whichever system you're using. All right, so when naming this, we actually say the name of the halogen, we end it with an O, so chloro, bromo, or, whatever else, iodo, things like that. And then we actually say the molecule. In this case, the molecule would be called difluoromethane because it has 2 fluorine atoms. Remember to name the location of the halogen if there are multiple locations, but since there's only 1 carbon in this molecule, we don't have to worry about that. Alright, now let's talk about rings. These are really easy to name. All we have to do is add cyclo to the front. Now let's talk about alcohol groups. For these groups, you just end the molecule with OL or all. Now let's talk about aldehydes and ketones. Alright, so both are the same thing. They involve a double bonded oxygen to a carbon, but the name depends on where the double bonded oxygen actually is. So if the double bonded oxygen is on the terminal carbon or the end of the carbon molecule, so the beginning or the end, then we have to use the aldehyde ending. But if it's anywhere else, we have to use the ketone ending. Alright, so now let's go over those endings. So aldehydes have the ending of al, and then ketones use the ending of -one. Alright, with all of that done, let's move on to carboxylic acids. Alright, so basically carboxylic acids are actually the combination of an alcohol group and a ketone group. And when naming this, you actually just add an oic acid to the end of the molecule name. So you would say like ethanoic acid. Alright, now let's talk about esters. Alright, esters are basically an aldehyde group and then an oxygen bonded to the same carbon. So the oxygen is actually going to be inside the molecule, in between the carbons. I know it's a little difficult to imagine, but here's what it looks like. So when confronted with naming these, you would actually split the molecule along the oxygen in the middle of the molecule, and then name each side. You would name the side with no aldehyde group first, and then the other side, and then end the entire molecule name with O8. Now let's talk about amines. This is when an NH2 is connected to a carbon on the chain. So when naming these, we actually have 2 methods to naming them, but I'm just gonna go ahead and stay with the prefix version because I think it's the easiest to learn. And so in this case, we would just use amino as the prefix and name everything else the same. In the example above, the molecule would be named 1-aminopropane. We would still need to use the 1 because we need to mention where the amine group actually is. Alright, we're almost done. Let's talk about nitriles. A nitrile is a functional group where a nitrogen molecule is actually triple bonded to a terminal carbon. You can't really have a nitrile group in the middle of the molecule. It's not possible. Alright, so let's look at this example. This would be named propanonitrile because the nitrile group on the first carbon. We don't have to mention where the nitrile group is located because it's always going to be on the first carbon, either way. So basically an amide is a carbonyl group and an amine group attached to a carbon in the molecule. Alright, so when naming this molecule, you just name the molecule and then end with amide. So it's really easy to understand and memorize. Alright, last but not least, we have ethers. An ether is basically an oxygen in the middle of the molecule. When naming this type of molecule, you say the 2 parts of the molecule are separated by the oxygen and end with ether. Now don't forget to add the -il at the end. So let's look at this molecule. Alright, so in this case you would name this molecule ethyl-ethyl ether because the carbons separated by the oxygen make ethyls. Alright, we've reached the end. That's all. Thank you for watching. Next week we're going to talk about measurements, significant digits, and uncertainties. Hey, so you actually made it. Alright, so you made it to the end of the video. Nice job. Props to you. Alright, so there's a bunch of stuff here. So be sure to hit the like button, like my Facebook page, follow me on Twitter, follow me on Snapchat, things like that. Do all of that. Alright, and then also there's a gear icon right beneath the video. Go and click that. You need to get notifications. Get notifications for my videos, please, and watch all of them. Go to my videos and just watch every single one of them twice. Just watch all of them twice, and then like every one of them, and then share them to all your friends. That would be great. All right. I hope the video helped. I'm actually editing the video right now. It's kind of excited that I'm actually able to talk to you because you actually made it. No one usually makes it. I don't know what to say. So How's life? It's going pretty well, yeah. So, I don't know. Yeah, you can leave now. You don't have to stay.